Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're diving into another fascinating topic. We're currently in the advanced topics season, and today we'll be zeroing in on the concurrency in Java 9 Plus chapter, specifically focusing on the stack walking API. But before we get started, let's make sure everyone is on the same page. For today's episode, it would be helpful if you're familiar with Java concurrency basics and concepts such as threads, stacks, and possibly even some historical context about Java's evolution in handling concurrency. But don't worry if you're not, as we'll walk you through the necessary bits along the way. Here's a quick outline of what we'll cover today. First, we'll dive into the history and motivation behind the stack walking API. Then we'll break down its key features, explore how it compares to older methods of stack inspection, discuss real-world implementations, and wrap up with best practices and common pitfalls. To kick things off, I have an interesting quiz question for our listeners. What are some key advantages of using the stack walking API over traditional stack trace mechanisms in Java? Think about that for a moment while we delve deeper into the topic.
That's a great question, Sheila. To help our listeners, let's break it down a bit. Historically, Java relied on stack trace elements for debugging and error handling. While this was useful, it came with limitations. The stack walking API, introduced in Java 9, aimed to provide a more efficient and flexible way to interact with the call stack. So, as you ponder the quiz question, think about performance, flexibility, and potential use cases.
Exactly, Victor. Now let's dive into some key terms and prerequisites. First off, what is a stack in the context of Java, and why is it important?
Great point, Sheila. In Java, a stack is like a tower of information about the active parts of a program. Each time a method is called, we add a new layer to this tower. This layer, or stack frame, contains details like local variables and where to return when the method is done. When the method finishes, we remove its layer from the tower. This structure helps Java keep track of what's happening in your program and in what order.
Thanks for that explanation, Victor. So, why was the stack walking API created, and how has this concept evolved over time?
To understand that, we need to look back at how stack inspection was traditionally done. Before Java 9, developers had to use methods that captured the entire stack trace at once. It was like taking a full snapshot of our information tower, even if we only needed a small part of it. This approach was often slow and inflexible. The stack walking API, introduced in Java 9, was created to address these issues. It's like having a smart camera that can focus on and capture only the parts of the tower you're interested in without the need to process the entire structure. This approach offers greater flexibility and efficiency.
That sounds like a significant improvement. Could you give our listeners an example to illustrate the differences between the traditional approach and using the stack walking API?
Absolutely. Imagine you want to log only the method names from the current stack trace for debugging purposes. Using the traditional approach, you get the entire stack trace and then go through it one by one to extract the method names. It's like writing down every detail of every floor in a skyscraper, then going back through your notes to list just the room numbers. In contrast, using the stack walking API is more like having a smart elevator that can stop at each floor and tell you just the room number, without the need to write down all the other details. This approach is much more streamlined and efficient, especially when dealing with large and complex programs.
Got it. Now, let's talk about some edge cases and real-world implementations. Are there any particular challenges or situations where the stack walking API truly shines?
One key area where the stack walking API excels is performance-critical applications. Since it avoids the overhead of capturing the entire stack trace, it's particularly useful in high-frequency operations like logging or profiling. Another area is security. The API allows for more controlled exposure of stack information, potentially mitigating risks from stack inspection abuse.
Interesting. How does it compare to similar technologies in other languages or frameworks?
Good question. In the context of other languages, the stack walking API brings Java closer to what languages like Python and Scala have been offering with their own stack inspection tools. However, Java's solution is more efficient and fine-grained, thanks to its ability to process information on demand, which is a step ahead in terms of performance and customizability.
Are there any common misunderstandings or pitfalls that developers should be aware of when using the Stack Walking API?
Absolutely. A common pitfall is misunderstanding the scope of stack frames. Developers might assume the API always includes certain frames, but it can be configured to omit internal or platform-specific frames, which could lead to incomplete or misleading stack information. It's essential to read the documentation and understand these configurations to avoid such surprises.
Great advice, Victor. How about best practices, tips, and tricks for our listeners?
One of the best practices is to use the filtering and mapping functions provided by the API to keep your stack walking efficient. For instance, you can tell the API to keep class references, which can save time by avoiding unnecessary class loading. Also, always handle exceptions gracefully when performing stack walks, as they can expose internal states that may change between different Java versions.
Thanks for those insights, Victor. Before we wrap up, do you have any fun facts or interesting anecdotes related to the Stack Walking API?
Sure. Did you know that the Stack Walking API was one of the features touted during Java 9's release as an efficiency game changer? It was particularly praised for helping developers optimize their applications without diving too deep into the internals of stack management. Plus, it's a great conversation starter among Java enthusiasts.
That's fascinating. Now, for our listeners eagerly waiting, the answer to our quiz question: the key advantages of using the Stack Walking API over traditional stack trace mechanisms include better performance due to its on-demand processing, increased flexibility in selecting specific stack frames, and enhanced control over the stack inspection process. To summarize today's episode, we covered the Stack Walking API, its history, key features, use cases, real-world implementations, comparisons with similar technologies, best practices, and common pitfalls. Coming up next in our series, we'll be looking into var handle and enhanced atomics, another exciting advanced topic in Java 9 Plus concurrency. If you enjoyed today's episode, make sure to subscribe to our podcast and leave us a rating. Your feedback helps us improve and bring more valuable content to you. Thanks for tuning in.